Today I want to talk to you guys about galaxies. Galaxies, we said the other day, are a group of stars, dust, and gases held together by gravity. Held together by gravity. Gravities are classified into three types based on shape. So we have three types of galaxies. They are based on their shape. The first type of galaxy is the elliptical galaxies. Elliptical. Elliptical is describing the shape. It's kind of like an ellipse, which is an elongated circle, kind of like a football shape. This means that it is fatter in the middle than it is on the ends. It bulges. In the center. These galaxies are among some of the smallest galaxies and some of the largest known galaxies. So they come in all sizes. The smallest and the largest known galaxies are elliptical galaxies. They are very old, and they have a little or no new star formation. Next on our list of galaxies shapes are the irregular shaped galaxies. And as you can figure out from the name, these have no defined shape. These galaxies are very young, and there is only a small number of galaxies that are considered to be irregular shaped. So only a small number of galaxies are considered to be irregular shaped. If you only remember two things about galaxies, you should know the name of our galaxy is the Milky Way, and that we live in a spiral shaped galaxy. Milky Way. The Milky Way galaxy, if you are looking at it from above, is going to look like this. It has these arms, and it seems to be spinning really fast. The way that I drew it, it looks like it's going in this direction. If you were to approach it from the side, you would see a central disk and a bulge in the center. The bulge has old stars. And it kind of looks like an elliptical galaxy. So one might guess that elliptical galaxies were once spiral-shaped galaxies. It has the thin disk around it, and the disk contains the young stars. Our solar system is in one of these spiral arms. The disk is very thin, and it's very dense. And it rotates very fast. If we are looking at this from the top, this is the old, and this is the young. The distance, the size, rather, of the Milky Way galaxy is 100,000 light years. That means it would take light from one portion 100,000 years to travel across the whole span of the Milky Way galaxy. But what does that actually mean? I want to talk to you guys for a moment about light years. The speed of light. Meaning, how fast does light travel? Well, light travels at 3 times 10 to the 8th meters in 1 second. In 1 year, so 1 light year, light is going to travel 9.5 times 10 to the 12th kilometers. That's a pretty big distance. If it was traveling 100,000 then light years, now we are talking about 9.5 times 10 to the 12th times 100,000, and that gives you an idea of how big the Milky Way galaxy is. The distance from the Earth to the Sun is pretty close. It takes 8.3 light minutes. So if our sun were to blink out of existence, it would take us 8.3 minutes before we realized anything had happened to it. The next closest star is called Proxima Centauri. Proxima Centauri is only 4.3 light years away. So it would take light 4.3 years to reach us. Polaris, which is the North Star, is actually 320 light years away. And Andromeda which is our next nearest galaxy, is 2.5 times 10 to the 6th light years away. I want you guys to get a sense of when we're talking about a light year, how we are talking about a really immense distance. So I guess there's actually 4 things I want you to take away from today's lecture. 1, we live in a spiral-shaped galaxy and it's called the Milky Way. 2, that a light year is actually a very big distance, and we are talking about when we're talking about the vastness of space. And the other thing I want you to remember about the universe is if there are 100 billion stars in a galaxy, and that there are 100 billion galaxies in the universe, we are talking about many, 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 many stars. 100 billion billion, right? 100 is a lot of stars.